Hello everybody. We are now doing the sales presentations for our project. Our project named Big Force Monitoring Unit. I'm Ian Cho and my teammate Ho Hon Kwon. Okay, we may start now. Okay, this project is doing the Big Force monitoring sensor, and this project is have some requirement from our client. Our clients, Optum's company, have give the essential part and the additional part for this device. And for the time issue, I'm not go through all the part for the requirements, but I can tell you all the requirements are achieved and maybe something transcended. Okay, let's see it. Okay, first of all, you can see the device. This is a real portable device. Okay, maybe a little fake because of battery case. Maybe later we will make it small, thinner. Okay, you can see this device adopted the large LCD. Is a 3.2 inch high resolution color display, and you can see this is the menu. The menu system is easy to read, and you can control everything. Okay, maybe just doing one test for it. Okay, just press S1. Okay, the system waiting for trigger. We press some force into the sensor. Okay, you can see the device not only display the test, is display the graphic. Okay, it's a plot force curve. They have a 6 swing gauge force sensor, so they have a 6.9 into it, and all the details also show in the right hand side. Okay, and have some testing parameters. I will introduce later. Okay. That is a very high readability. Okay. And I want to introduce this device adopted a sensor registration mechanism, because this device adopted 6 swing gauge force cell, and the swing gauge force cell, the signal is very low, so have a op amp into each sensor, and then the signal through the ADC enter to the device. Okay, you can consider maybe not all the testing you adopt all the sensor. Okay, maybe this test I only have only 4 sensor. Okay, for the testing. So the user will unplug some sensor like sensor 1, sensor 3, and sensor 5. Okay, now only have a 3 sensor on it. Okay, and the system, I'll just go to the registration mechanism, will automatically detect which sensor is connected, and you may just press one button for confirm and register the sensor 246. Okay, why we adopt this mechanism? Because you may consider the ADC, if you not connect the sensor, the ADC pin is in high impedance. If in high impedance, maybe some EMI will enter to the ADC pin and make some noise to the force curve. Those data is useless, and we don't want to save the data, and we don't want to transfer it into the database. Okay, so this mechanism is prevent the useless data when you not connect all the sensors. That means this device have the ability to use 1 to 6 sensors. Okay, just choose by the user. Okay, we adopt all the sensors to the system again. Okay, for the other testing. Okay, this is we want to talking about the calibration method. For some tests, we discovered that our strain gauge is totally output the linear curve to the device. We adopted once all the sensor, we have adopted the 55 kg capacity for sensor. Okay, we try to add a lot of the counter wave to testing and plot the graph like that. This is totally linear. So the sensor calibration problem is how to define the 0 point. Okay, the method is so easy. When this doesn't collect, doesn't apply any force to the sensor, that is a 0. So we have a mechanism to take this 0 point. Okay, just go to the sensor calibration and sensor set 0. Just enter. This is the level is calibrated by last time. Okay, why this the device will show this? Because all the data is storage into the EEPROM. Now we calibrate again and pass save and exit. Okay, now all the calibrated data saved to the EEPROM. Even you close the device, the sensor not need to recalibrate again. Okay. Other benefits for our device is user can define anything. Okay, we just go into the system preference to show that. Okay, this is the system preference for this device. Okay, you can see the S1 button is for test sample. It's how many reading you take in one test. Now, how many is saved into the system?
100.
100. Maybe this device also can defined by user to set 1 to 100. Why adopt 100? Because we want the curve more smoothly, and maybe you get a lot of analyze into the force curve. So more reading is better for the testing. Not only take 7. We choose we allow to choose it by the user 1 to 100 also okay. And the second is the time interval. Maybe now we adopt 100 times. How many time interval on each reading between each reading? Okay, now how many? 20. That means your test will be 100 times 20 milliseconds. That means your test total time is 2 seconds. Maybe I don't want just 2 seconds, maybe I make 3. Okay, I try to make in 30. Okay, how I'm going to show you how to change the level. Okay, the user, the range is UFI definable to 1 to 100 ms. Also okay. Okay, now 30.
Yes.
Okay, and other thing is SV is a trigger threshold. This is very important for when you starting the test, because you can't all the time in the test and all the time take the reading. You can't do that. Maybe when you want to start this method is so easy. Just pass some force into sensor, and maybe this force more than the trigger threshold, then the testing will start. Okay, how many threshold now we apply on it? One. Okay, maybe we change to 1.2 or something. Okay, just show you how to set it. Okay, 1.0. Okay. Yes. Okay, so you need to pass more force next time for the test. Okay, we try to do that again. We test again. Okay, exit. Okay, we do the test again. Now is take about 3-second test for 100 reading. Oh, I need to be slow. Okay, so you can see there have a lot of curve. The 4, 5, 6 is my sensor. Is start is a little bit lagging, and on one you start the 1, 2, 3, the wet one, orange one, and the green one is faster than me. So response time showing curve is faster than me. That is reasonable. Okay. All the thing is you can set it to our system, and all the system parameters the preference, sorry, and is saved to the EEPROM. When you turn off the device and turn on again, all the system preference still on the device. Okay. Okay. The more important is how to analyze the force for the brake is good or bad. We have got two methods. Two mode. Okay. The mode 0, we said that is a safety threshold analysis. That is easy. Because if you want the brake, if you want decide the brake is a safety, maybe you just simply measure how many force applied into the brakes between the disc brake and this pad. Sorry, this and this pad. Okay, system will take the maximum speed and compare this maximum speed of the curve to the safety threshold. If the maximum speed is more than our threshold, then the system will show pass. Otherwise, will show failure. We can see it on here. Okay, Hong Kong is set it. The last time is 10. You can see the safety line here, and he pushed around about 2 sensors, 1, 2, 3. Okay, sensor 1, sensor 2, and sensor 4 is passing the test. Maybe, okay, or the 6 is also passed. The sensor 3 and sensor 5 is failure. Maybe you can't see the LCD because the text is too small, but I can tell you the green is showing the pass, the red one is the failure. Okay, maybe we do the test again. Okay, we just go out. Maybe I change to the system the safety threshold to more, but maybe 12. Okay, now from 10 we change to 12. Okay. Okay, save it. Okay, exit again, and go to the test. Maybe I just apply less than 12. Maybe you pass more than 12. Okay. Okay. I'll just start it. Okay. This is very clear. Okay. My sensor is 4, 5, 6. Is purple, blue, and green. All failure. Below the 12 kg. Hong Kong is all pass. The red one is very high. He applied 29.34 kg on it, and the yellow one is 22. He applied 21, and the last 4 ones is the orange one is 13, just 13. Okay, okay. You can see if the system can define which sensor is pass or failure the safety threshold. Okay. We talk to mode 1. Okay, the other one. Okay. Okay. Maybe only just test the safety threshold may not accept to the engineer anyway. Okay. But that is very difficult way to think how to make the curve is good or bad, because we are not professional in the railway. Okay, but we can compare. Okay, okay. The mode 1, the principle is very simple. If the client will have one verified brake, and we take this brake as a force curve and compare to the other brake to take. And compare it for this reference curve and compare to the other curve. So you will get the result is how many curve is matched, percentage is matched to the verified and the testing sample. Okay. Why we think about that? Because you think the swing gauge have the size maybe a little bit thick to the between this and this pad. If the size a little larger and smaller, the curve will totally different. But that is very that is difficult to decide how to apply the logarithm to the device, but we apply to the reference that's very simple and so easy. I'll show you how to do that. Okay, first of all, we need to take the reference sample. Okay, we just go to the sensor calibration again and choose the reference curve. Okay, this is last time I take it for the device. Maybe I take it again for you. Okay, you can choose which sensor you want to take the sensor force curve. Okay, now you select the sensor 4. Maybe I add well, maybe I use sensor 1. Okay, this one is it. This one. Okay, this one. Okay, and enter. This sensor 1 will take the reference force. Then Hong just put some force as a reference. Okay, this reference curve is heating. Okay, maybe you can see the upper and lower have a dot line. Okay, this is the tolerance. Okay, you can't only just accept using the reference curve. You need to apply some tolerance to the reference curve. Then if the testing sample within this range, that is a match, and otherwise it's unmatched. Okay, maybe we want to change the tolerance. I'm now setting the upper tolerance. Now it's applied 1 kg for tolerance, so maybe I'll add something 2, 3 or 3 kg. It's alright. Okay, and that's it. Now you can see the dot line is a little bit away to the upper to the sensor curve. Maybe the lower curve is now maybe I decided again, maybe I make it larger to 4 kg. Okay, so you can see that the lower sensor, the lower limit is the range is larger than the upper. Total range is using for the matching for the reference curve. Okay, we go out. Okay, and then the reference curve will save into EEP room. Okay, start the brake test. The brake test again. Okay, you can see the dot line with a range with this tolerance range is applied into the device, and the system will show which each sensor how many percentage is matching and within to this reference curve. The sensor 1, red one, only have 54. Sensor 2, the orange one, not in the curve, only 8%. Sensor 3, 5%. Sensor 4, 21. Sensor 5, 4%. And the better, the sensor 6, 25. Okay, can you make better to your reference again? Okay, we do it again. Maybe you just make for the better for this for your reference curve. Okay. Oh, you failure. Okay. He using the sensor 1 now 55 matching. You failure. Okay. The device can show you how to matching the existing web-file big force as a reference to compare the other testing and make the decision is just the force is matching, or maybe it is 1 times lower, faster than the reference, maybe higher, lower force to the reference. The engineer can use this data to decide what is the maintenance time and see the trend, I think. Okay, and other thing is this about this device is of course the device can save the data to the SD card. Okay, we have got a SD card hole in here. Okay, here. Okay. Then you just plug the SD card on it and just pass. Okay, maybe just here. We haven't got the SD card here. Okay, so the system will show failure. Okay, but I have shown that in the PowerPoint. The system will take the time and the date will be using for the make a folder, and the file name will store to this named data named folder and save the time to the as a file names. Okay, and also the timestamp for the file system also included to the file. So you not only show the file is making from the millennium years to 2001 January 1, not like this. Just have a real time when you save the file. Okay, and of course the file contain dates, time, some system preference, and all the text value into the file. The file is saved. The file type is SCV. CSV. Sorry, CSV. Okay, you can put the graph into Excel and make the graph again. But I think our LCD is also do the same. Okay, and other benefits is we already done the remote monitoring station program. Okay, we just show you how to do it. Okay, we use Python 3 to write the monitoring program. Here have one RF serial transceiver. Okay, this is quite similar to CB. This one called APC 220. Okay, the distance around 2 km in the open area work in 400 something megahertz, and you can change the frequency. And okay, we do the test now. Okay, just plug this device into the computer, like there. Okay, I just put it into my computer and run the Python program. Just double click the Python program, and the Python program say waiting for your trigger. Now just press send. Okay, now you can see the Python program now will save. At the end, the graph is made. And the graph will also save the file, maybe a photo. Okay, you see the time? It's the same to the device. It's real things, not fake. Okay, we can do it again. Maybe you take the test again. Okay, and send it again. Also is saving. Okay, successful. Oh, other one. Okay, you can see here just 2 feet, but we really tested in 2 km. It's okay. Okay, and the file is other one here. Okay. So we really done the program for remote monitoring station, and this maybe this program we can save it through the internet to this maybe database server like SQL, and make it the for the trend analysis for the maintenance. I think okay. That is all about our product, the Big Force monitoring device. Thanks for watching, and okay, thanks you, Hong Kong.
Yes.
Okay, bye bye.